Hello student, let's solve next problem. So we have this one. So this problem looks a bit complicated, so let's move on. Okay, let's move on. Let me close this one, and then let's capture this one and then solve together. Well, there is a solution over here, but let me solve this one in a slightly different manner. So over here, yes, I may need a lot of space over here. So problem looks like this. Okay, so ST is that way. So first, what we wanna do is, let's say, because eventually we wanna prove this one, right? This is something we wanna prove, okay? This is something we wanna prove, and then here we have something like this one, right? Something like this one. So we need expression for this one, okay? So let's get this one. So we have ST over here, so we wanna have a DST. Right? So again, we wanna take derivative ft dt. Let's say this one. Let's call again. I'm calling this entire thing as f t and w t. T and w. That's what I'm doing. And f w d w. Right? And then plus f 2w. 2 dw square. This is Taylor series expansion. Let me change it to black color. And if we take derivative with respect to t, okay, t, then, well, where is t? We have t over here and t over here, right? So again, differentiation is inverse of integration. So, well, if we take derivative of this one with t, it is 0. So what we have, 0 plus now second term about this term, right? This term. So mu t, we have mu t, and then st, right? Take derivative, and then third term, if we take derivative, then it is sigma t, st, and this entire thing is actually take derivative. So t, so actually, yeah, this is t. I forgot this part. So, oh, what is going on? Okay, well. Okay, sorry about this part. Okay, sorry about this part. So take derivative. So we have dt. So we have to move this one. Let's move this part slightly, and then we have dt. Okay, we have dt over here. Okay, so this is first term and the dt. Okay, we have this one. And then let's take derivative of this one with this w, but as you can see, it is not a function of w. So this is actually 0 dw, and then again 0 dw square, something like this one. Okay. So and then actually this is again problem. So let me delete this part. Okay, dt. Okay. So this is basically this part. This entire thing is basically ft part. Okay, ft part. Okay, so which means that dst is mu t st dt plus sigma st dw, right? And then if we rewrite this one, divide each side with st, then we will dst st equals mu t dt plus what? Plus sigma dw, something like this one, right? Now we have also log over here. So, well, it is basically, if we write this one, this is basically log st over s naught is log st minus log s naught, right? So you can interpret this one as the integration from t to t over t log su, something like this. So we also need to calculate something like this. Okay. How can I calculate this one? So t log st, then it is the, well, we can regard, let's regard log st as a gst, some sort of function. Then it is the gt dt plus g s ds plus g, actually take derivative g s ds plus g double s, double derivative, and ds square. But this is again not a function of t, so it is 0 dt. And if we take derivative with respect to st, then log st prime is 1 over st. So we have 1 over st, right? 1 over st, and then ds. Okay? And then if we take derivative again, now if we take derivative again, then we take derivative, so it is the what? St minus second one, right? So this is 1 over 2 and then minus st minus square and ds square. Okay? Then we can do some slight exercise. Then, well, it is the ds over s plus half of, actually now it is minus over here, so it is minus, so actually I want to delete, so minus of s ds square, isn't it? But now we have this expression, so we can just plug it over here. Then what we have is basically this is the mu dt plus sigma dw minus this one square, so it is the sigma square dt, sigma square, and then dt, oh, what is going, minus, sorry, something is, this is a minus, let me write this small, and then sigma square, and then dw square, so it is mu, oh man, this is pain, okay, go up, and then mu dt plus sigma dw minus sigma square dt. Remember the square term. What I'm just doing is that, okay, I'm just it's a quick notation, dt, what I just did is that ds s square is basically mu dt plus sigma dw square. So which is sigma square dt square plus 2 sigma mu sigma dt and then dw plus sigma square dw square, but this is 0 and this is 0, so and then this is dt, so sigma square dt, and this is this part. Okay. Okay. So we have this one. So we calculated this one. So actually we have divided the half t, right? So, well, let me clean up and we write down in more clean way. Now let's delete this part. Then using this one, what we have is very interesting relationship. What we have a very interesting relationship. So d log st equals mu minus sigma square over 2 dt plus sigma dw, right? So now we have this term. So if we integrate, let's do the integration. Okay, let's do the integration over this one, each side. So integration of each side, then let's change in notation u and then 0 to, in the problem we have to integrate from 0 to t, right? 0 to t is log st minus log s naught, okay, which is equal to integration of this part. So in the first part, if we integrate the first part, it is the mu sigma square and then dt is simply t because 0t ds is simply t, right? We run this one. And about this second part, we cannot do much. So we can simply write down 0 t sigma dws, right? Right? And it is a log st of s naught, which is equal to mu t. In the problem, mu minus square t plus 0t sigma dws, 0t. So let's move this one over here. Now, well, let's move over here, somewhere over here, and then clean up this part. And then what you can do is you can compare. This one and this one. So clearly we have this term over here, right? Close this one, right? And then we have this one. So, well, remember what we have is over here. So from this one, from this one, if we take integration, which is basically I'm using this one. So actually, let me use u integration. So which is basically mu t. Okay, mu t, and then, well, basically here I'm assuming the mu is constant, but it doesn't change the answer much. So plus sigma dw 0t. So you know these two terms is exactly same to these two terms over here, right? So we can move over here. Okay, we can move over here. So here it is basically TSS, right? Minus T, but well, here I'm for simplicity, I am assuming the sigma is constant, but basically this is integration of this part. So well, it is 0 T TSS minus 1 over half of sigma square, right? ds 0 T, right? So if we now we have this one, so if we multiply 2 in each side, then we can recover this one. Okay? Well, this is a bit, I'm doing a very complicated way, but if you follow this process very well, I think you can do it. So again, let me, because it is very important, let me summarize what I did just before. So let me open another one. What I just did is from this integration equation, original equation, I just take derivative, and what I did is I just derived ds u. Let's use the same notation. U is sigma u du. Actually, I divided as each side. Let's divide later on. As u dt. Actually, again, let me use t. So dt from this one, st is mu t st dt by taking derivative of each side plus sigma t st dwt. And in addition, why I just proved is that in the long process over here, what I just proved is the log st equals mu t minus 2 over sigma t square dt, and then plus sigma t dwt, right? And then in order to derive this one, I integrate both sides. What I did is I integrate each side. If I integrate it, which becomes log s big T minus log s naught equals integrate. So what I did is 0 big T mu u du minus half of du square du, and then integration of this one. So basically what I did is zero t sigma s d double s, right? I derived this one, and then what we can show is basically we collect these two terms together, sigma u, well, I'm collecting this term and this term together. So actually, this SU same to mu u du plus sigma u dwu, right? And then minus sigma u du, okay? Okay, actually I need this square over here, but this is basically from here. What I can show is that dt plus sigma t dwt. So I am plugging this one over here. So this is 0t dss, okay, dss, and then minus half of 0t sigma square du, okay, du. And then this one is simply log st over s naught, right? And then next step is I multiply 2. I want to solve in terms of this one. I want to solve in terms of this one. So basically 0, let me go up. T du is basically now multiply 2. I move this one over here. So, well, let me make equation consistent. So minus 2, because I move this one over here and this one over here. So minus 2 log st s0, right? st s0, and then plus 0t ds over s. Let me write down in a clean way. T ds over s, and then t is exactly same to this one. Okay, exactly same to this one. So we are done. Basically, we are done. Ah, sorry, because we multiply 2. So yeah, this is. Well, I need 2 over here. Okay. Because I have to multiply 2 each side. So we just proved it. So it's basically long proof, but because we have something important over here, these things are important. They are important. So I deliberately solved this one in long way. And then this kind of process called geometric. This kind of process is very important. So it is geometric Brownian motion. Yeah, I just wanted to show you this one. Of course, the real problem is far simpler. There are simple ways to solve this one. So S01, so, well, from this one, S0 looks like this one, and then we apply theorem by each side. This is actually what I just showed you. Yeah, this time, and this is exactly the same. And by, right, this one equals this one. So, well, instead of relying on exercise 9.2 something, I just want to show everything from the beginning. So I showed this one same to this one, and rearranging it, we have this one. So yeah, I proved this one the long way. Okay, so this is very important. Very important. This geometric Brownian motion is very important. This geometric Brownian motion is very important. So please, at least try to get the. You don't have to memorize it. You don't have to memorize it, but please try to be familiar with this one. The importance of geometric Brownian motion is because we use this a lot to model the stock price. For example, like S is stock price. For example, S is kind of stock price. Then DS is a change in stock price. Change in stock price. So natural DS over S is basically stock return. Right? Stock return. So it is one way of modeling stock return. So here it means that stock return has some drift part. It is like expected return over period, and it is shock to the stock return. You know, we don't know the stock return exactly, so there is always shock. So this is part is shock, and this part is expected return. Okay, expected over some period. Professor out.